Here we'll take a look at a right triangle and some facts about a right triangle. Notice on the right we have a right triangle. And notice that a right triangle consists of two legs and a hypotenuse. Here are some facts about a right triangle. The hypotenuse is opposite the right angle and is always the longest side of any right triangle. The largest side is opposite the largest angle, and the smallest side is opposite the smallest angle. Another fact is that the sum of the interior angles of any triangle, not in particular right triangle, but any triangle, is 180 degrees. And one important last note is that the triangle is one of the most strongest structures in nature. Now we'll take a look at the Pythagorean theorem. And here's the Pythagorean theorem as it's formally written. We have c squared, where c is our hypotenuse, is equal to a squared plus b squared. But notice in our problems, we never really find c squared, a squared, or b squared. We'll simply find c, a, or b. I'm going to bypass a, b, and c, and here I'm simply going to use leg, and hypotenuse. So I'm going to list out this right triangle as having two legs and a hypotenuse. I'm going to write out the Pythagorean theorem in this fashion. I'm going to write it as the hypotenuse squared is equal to the sum of the legs squared. Right? So keep in mind, we never find the hypotenuse square. We always find the hypotenuse. So we're going to take the square root of both sides. So we have the following formula. The hypotenuse is equal to the square root of the sum of the legs squared. We can also find the leg of any right triangle by using the following formula. The leg is equal to the square root of the hypotenuse square minus the leg square. Now let's take a look at an example. Here we're asked to find the missing side length. So notice that the side length we're trying to find is opposite the right angle. So we're actually trying to find the hypotenuse. So I'm going to use that following formula. The hypotenuse is equal to the square root of a leg square plus the other leg square. So I'm going to substitute in our legs as 8 and 15. So the hypotenuse is going to equal to the square root of one of the legs squared. So I'm going to use 8 squared plus the other leg squared, which is 15. I'm going to simplify. 8 squared is 64 plus 15 squared is 225. I'm going to add 64 and 225 for a total of 289. And we have a hypotenuse of 17. Right, so notice that hypotenuse should be the longest side, and it is in fact the longest side. Now we'll take a look at the 6 trig functions in Chief Sokotoa. Chief Sokotoa is simply a mnemonic device to help one memorize the 6 trig functions. So let's take a look at these 6 trig functions. Here we have the 6 trig functions laid out: the sine, cosine, tangent, and their reciprocals. Before we look at these 6 trig functions, we're going to talk about what's called the standard labeling of a triangle. And the standard labeling of a triangle is simply denoted by the capital letters are your angle measures. So here I have angle A, I have angle B, I have angle C. Our side lengths are lowercase letters. Keep in mind that your side is opposite your angle. So if we take a look at angle A, notice that the side opposite angle A is side length A, and I'm going to denote that with a lowercase a. Now we'll take a look at we'll take a look at angle B. The side that's opposite angle B, it's side length B, and I'm going to denote that with the lowercase b. And then lastly, we have our right angle, which is angle C. So the side opposite angle C is side length C, which is our hypotenuse. Now we'll take a look at the sig trig functions. As in the mnemonic Chief Sockatoa, it alludes to the sine, the cosine, and the tangent. So in the psi part of Chief Sockatoa, it alludes to the fact that the sine is the opposite over the hypotenuse. The ka in Chief Sockatoa alludes to the fact that the cosine is the adjacent over the hypotenuse. And Toa from Chief Sockatoa alludes to the fact that the tangent is the opposite over the adjacent. We also have the reciprocals. The reciprocal of sine is cosecant. The cosecant is the hypotenuse over the opposite. The reciprocal of cosine is secant. The secant is the hypotenuse over the opposite. And lastly, we have the cotangent. The cotangent is the reciprocal of the tangent, and the cotangent is the adjacent side over the opposite side. So let's take a look at an example. Okay, in this example, we're asked to find the 6 trig functions for our triangle. But our triangle is missing a couple of items. The first item is that it's missing its angle notations. So I'm going to call this first angle angle A. I'm going to call the second angle angle B. And our right angle is angle C. Right? And we want to find the sine, cosine, tangent, and the reciprocals for angle A. The first thing we must do is we must find our missing leg. So I'm going to go back to our formulas, and we saw that the leg was equal to the hypotenuse squared minus a leg squared. We see that our hypotenuse is 29, and we have our other leg is 21. So we're going to write that out as the square root of 29 squared minus 21 squared. 29 squared is 841 minus 21 squared, which is 441. Next, we have 841 minus 441 is just 400. And we have a leg length of 20. Right, so in order to find the 6 trig functions, you must know all of your side lengths. So we use the Pythagorean theorem to find the missing leg. Now, in order to set up the trig function, we're going to use Chief Sockatoa. When we use Chief Sockatoa, however, we must have what's called a reference angle. And a reference angle is no more than an acute angle. Keep in mind from our geometric definitions, an acute angle is an angle that measures less than 90 degrees. Thus, in this right triangle, there are 2 reference or acute angles. There's angle A and angle B. Since we want the 6 trig functions of angle A, we're going to use A as our reference angle. And before we use Chief Sockatoa, we're going to label our sides according to our reference angle. So when we label the sides of our right triangle, the first side I'm going to label is my hypotenuse. So I'm going to label the 29 side length as a hypotenuse. Next, I'm going to list out the side opposite to angle A. So we have angle A. We have the 21 side length that's opposite to A. So this is our opposite to angle A. And then lastly, we have our 20 length side as our adjacent to side. So that's adjacent to A. So now we're going to write out our trig functions. So from Chief Sockatoa, we know that the sine is equal to the opposite, which is 21, over the hypotenuse, which is 29. We have the cosine, which is the adjacent over the hypotenuse. We have the adjacent length that's 20. We have our hypotenuse is 29. And then we have our tangent from Chief Sokotoa as the opposite over the adjacent. So we have 21 over 20. And next we have the reciprocals. The reciprocal of cosecant is secant. So we have 29 over 21. The reciprocal of secant is cosine. So we have 29 over 20. The reciprocal of cotangent is tangent. So we have 20 over 21. And thus we have our 6 trig functions. Next, we'll take a look at cofunction identities. And here's a definition of a cofunction and a cofunction identity. If A is an acute angle measured in degrees, then if angle A is an acute angle measured in radians, we have the following. Now, in our course, we don't use radian measures, we simply use degree measures, so we have the 6 formulas. Notice that the first formula says that the sine of A is equal to the cosine of 90 degrees minus A. The second formula says that the cosine of angle A is the sine of 90 degrees minus A, and so on and so forth. These are our cofunction identities. Now we'll use these cofunction identities to simplify some problems. So here we actually use the cofunction identity to fill in the blank so that each expression becomes a true statement. So in our first example, we're given the sine of A is equal to the cosine of blank. Well, if we take a look at our cofunction identities, we see that the sine of A is equal to the cosine of 90 degrees minus A. All right, so our solution here is 90 degrees minus A. All right, now let's take a look at the second example. The cosine of 30 is equal to the sine of blank. So we'll take a look at our formula. The formula says, I'm going to write the formula above the problem. It says that the cosine of A, that's equal to the sine of 90 degrees minus A. So I'm simply going to substitute A for 30 degrees in the formula. So we have the cosine of 30 degrees is equal to the sine of 90 degrees minus A, which is 30 degrees. So this gives us the following equation. The cosine of 30 degrees is equal to the sine of 60 degrees, which is a true statement. And we're actually going to check that using the calculator. All right, so the first thing I'm going to do is I'm going to turn on the calculator. I'm going to turn on the calculator. The first thing I'm going to do is I'm going to go into mode, and I want to make sure that I am in degree mode because I am working with degree measures. Okay, so that's the first thing. I want to make sure I'm in degree mode. So I'm going to hit enter to lock that in. I'm going to return to the home screen, and I'm going to enter the following. I'm going to enter the cosine of 30 degrees, and I have a value 8.866. I'm going to enter the sine of 60 degrees, and if my formulas are true, I should have the exact same value. Okay, so the cofunctions are equivalent identities.